Hello?
Hi,
Hi, how's it going?
good. How are you?
Doing good. Very good. All right, so if it's okay, I'll just jump right in with a technical question.
Yeah, sure.
Yeah, so I think we'll do some not necessarily coding, but more system design question today,
Okay.
just to keep it. I'm sure you've answered enough questions about hash tables for one day. So let's start with a distributed systems question. So the idea is that you've got a database
Okay.
that you're keeping in MySQL, some standard off-the-shelf database system like a SQL database.
Sure.
And we could even say for this purposes, for simplicity, there's just one table, and it's just
Okay.
and you're getting more and more rows in that table, and eventually you found that there's more rows that can fit in one machine.
Okay.
So you have access to multiple machines,
Mm-hmm.
and they're all networked together somehow. So can you
Okay.
think of a way to organize the database, just given that that you just have access to SQL, you don't have anything like you know any automated tools for distributing it,
Okay. Okay.
and just kind of generally describe what this is going to look like.
Okay. Sure. So the idea is I just have an access to SQL database from multiple machines where I can store the data. Right now it's going to the one machine and it cannot scale for the data that we are getting.
Mm-hmm.
I'm just making sure that I understood correct.
Yeah, yeah.
And somehow we need to partition this database in a way to query in future, as well as store distributed in multiple machines.
Yeah.
So let me clarify a couple of questions like before splitting the data.
Mm-hmm.
Is it so there are few ways. One is like usually like geographically, like if we have some country related data in this, for example, if we have a country code, we
Mm-hmm.
could potentially have our country or region code, like we can split the universe in like a multiple regions, like one is like a North America, South America, or America, Africa, and kind of a Asia Pacific, kind of probably like a three regions. We can split into three different machines to go like any data related to three specific to these regions go into specific machine, probably like a one layer, one machine where load balances these things. Somehow we need to have a component where get the data and decide which machine to go store this data,
So is the
kind of.
idea that so yeah, that makes sense that there's going to be a lot of
But
if we have so much data, it might be coming in
mm-hmm,
from different sources.
mm-hmm.
So would the idea be that country code is just something that's in the database, or is that also relative to who's asking for that data? Like, does the European users talk to the European data, and the North
Mm-hmm.
American users talk to the North American data?
Okay.
Well,
So
that is
are you?
kind of just a question of is that how you were thinking about it? That
Yeah, so that was probably my next question was so how the database will be queried in future, whether like a different regions will ask for a different region or they will just look for their own region data when
Mhm.
they query. So that's debatable or a clarification question. If it's going to be like a Asia Pacific people asking for data from European and as well as Africa, then like pulling the data from two different machines and then merging and then responding is going to be complicated, so we have to think a different way of partitioning this, probably a date wise, um, like anything probably like a old data we can keep it in like a backup database, like a one transactional database where you have only current month's data. If
Mhm.
anything older, you go to different machine, pull it from there. So depending upon the query pattern, whether always you get quite often you get for last week's, last month's, or last 6 months data that being queried, that can be kept in the main machine where we do the transactional, and the rest all can go into OLAP, like analytics database kind of model, I would think of.
Okay.
So
All right.
this
So
is the second
let
approach.
me just there's a couple questions back in there. So
Sure,
with
sure.
respect to the geographical regions, so that's definitely a very good way to start. So if this was the kind of system where there were country-specific data that was being read from and written to just with respect to that country,
Okay.
and that was and people in that region were the only ones doing it, then that's an excellent way to start. But let's say, for the purposes of this exercise, that's
Mm-hmm.
not the case. That let's say
Okay.
that all the data is stored centrally in one data warehouse that's
Okay.
located in one geographic area. So that's just to cover the first one.
Okay.
So then that was an interesting point with respect to the recency. So can you just sort of sketch out for me an algorithm of how that would work? So for example, let's say that if I'm reading from as I'm understanding it,
Mm-hmm.
there's going to be one machine in the front that is
Okay.
going to take in the query, and it's going to look at the time range that
Mm-hmm.
you are looking at, and based on the
Mm-hmm.
time range, it will farm that off to different machines.
Machines, correct.
Okay? So how then does that work with respect to so is there going to be, are you going to, so let's say that you were going to have that split into day, that or I guess you had said month or something. So
One.
by
Yeah.
month.
Mm-hmm.
So is the idea that every month you would add a new machine for that month, so that there's a machine for 2015 December, and then for next month you'll need to make a new machine that is going to host the new data, or do you sort
No.
of migrate the old data backwards?
Yeah, so migration is what I was thinking. I wasn't
Okay.
proposing to add a new machine every month. Um, yeah, since being the transactional database is the bottleneck where everyone insert and as well as query for the same month, that is going to be one machine, and the rest all like yeah, machine can probably um, can accommodate more than a month's data.
Mm-hmm.
So the rest all would go to probably one machine or two machine depending upon the size. Whether it can hold in just in one machine, then it could be just one machine, or it could be like more than one machine depending upon the size of the database. Um, that was what I was thinking.
Okay, no,
Yeah, if
I
you.
like that idea. So this is an interesting point. So okay, so you have one machine that's kind of the current ones, and then
Mhm.
you have maybe multiple machines that are holding the older data. So
Correct.
how do you split that up? So let's say that you like right now maybe um, you have one machine for November for December, and then
Mhm.
one machine for all past data. So you basically just
All
split
pass
into
data.
two.
Yeah. Yep.
Then you're looking at this in the future and you say, oh, whoops, the machine that right now has all the past data in it is about to be
Mhm.
full.
Uh huh. Uh
Oops.
huh. Yeah.
So now how do we split up that
Yeah.
data?
Yep, yep, yep. So in that case, not in that case. So we have to be design. We have to design to accommodate this. Definitely, it's going to be full. Yeah, the one machine for all past data is not going to just hold everything for next 10 years or 20 years. So definitely, there should be a space for adding more machines as and when needed in the design to go get the backup database. From multiple machines. So in a way, I would rather say probably like go for like a 5 years, 10 years kind of a database. So these are all like a a kind of a parallel partition, right? There is completely a new concept for vertical partitioning. A table can be like a, so I'm not technically like completely aware how the whole thing works. For example, the big data thing, Hadoop, they completely vertically partition the table. First off of probably 20 rows, sorry, 20 columns. First 10 columns would be stored in one, and the remaining 10 columns would be stored in different machine. But I don't have the technical depth of knowledge for explaining how that completely implemented, or how the whole thing works, the vertical partitioning. So
Okay, well,
that's
let's
what,
not worry
yeah.
too much about vertical partitioning. I mean, that's
Hmm.
certainly one way you could do it, but let's just assume that there's a relatively small number of columns. It's just that
Hmm.
there's more and more and more and more and more rows.
Data rows. Okay. Okay. So yeah. So considering the number of backup databases, I would probably suggest like going back like completely like up to 5 years in one machine, and complete the past like whole more than 5 years probably in one more machine. Kind of approach is what I would think of.
So let me see if I have this uh, if
Correct.
if I understand the
Mm-hmm.
scheme correctly. So
Mm-hmm.
so you've got some or I guess the one piece that's unclear for me is how does the data then sort of move and get migrated from how it is now to into the past? Like once you've decided that some row is old by some definition of old, maybe it's 1 month or 1 year or whatever. How do you
Mm-hmm.
decide where it goes, and
So
how does that
yeah,
migration sort of work?
yeah. So yeah,
And
definitely.
one
So.
other quick
Mm-hmm.
question is, when
Mm-hmm.
you do that migration, do you
Mm-hmm.
go over all the data, like in the entire history as you redistribute it? Or when you redistribute it, do you just take the current data and then push it sort of somewhere?
Right. So, so yeah. So what I would do, let's say this is what my decision. Like a component which decides to go find where to find the data, so that knows which server I need to go find the data.
Mhm.
Depending how it knows. So this is the strategy is, let's say I have the current machine which does the transactions and everything for the last just 1 month. Rest all I'm going to keep in a different machine.
Oh yeah, and
Now
just
we
just so
learn.
you know, if you want to, there's a little whiteboard if you want to draw on the little whiteboard, and there's also like just the text if you want to draw little boxes in the text. So if that helps you to explain it or to think about it, you have those options open to you.
Yeah, sure. Yeah, let me try that. I'm just, this is my second interview, just
Oh, yeah, no
trying
problem.
this one.
Yeah, there's a little button that has like a pen on it, and that's a little
Yep.
whiteboard, so you can
Yep.
draw stuff.
Oh yeah. So
Yeah.
yeah.
Hmm.
So this is, let's call it OLTP. This one, like a transaction database. So this is where the current data. So even before this, let's say we have a component called like the load balancer or whatever,
Hmm.
which decides where the database should be queried. So all the queries coming in here,
Hmm.
queries, the load balancer decides where to go. So this OLTP, when I say the transaction the last month, so less than 1 month old
Hmm.
here,
Okay.
and the query here, let's say we get for old data here, so greater than 1 month old data is going to be stored in this backup server. So in a
Hmm.
point where this is going to be filled completely, there should be way, like I said, this is going to be filled up. For example, we have for now 10 years of data here.
Hmm.
So right now we filled it up, and then there is no space in here. At this point, I wouldn't completely split this thing. I think my suggestion would be to just have add up one more server where the new data, whatever we back up from this server, will get into this machine. Like I have 1 month old here. Now I'm in the second month, so just 1 month old data will get into this new server.
Okay.
Now I need to find a way where to query from these two machines and then return back. Somehow that has to happen depending upon the query in the load balancer. Depending upon the query, I'll have to find whether just I need to go to backup server, or also backup server 1 and backup server 2, backup server 3. Depending upon the query, I would just add this up. So that's probably is what that's what I was thinking of. I wasn't thinking. So there is one other way is like I have the backup, complete backup, 10 years of data. I wasn't thinking of splitting this into, like, I have 4 machines now, splitting into all 4 machines. I wasn't thinking of that solution though, for some
Okay.
reason. Yeah.
That's fine. So let me see if I understand the path here. I guess I'm a little bit confused. So the load balancer at the beginning looks to see if it's within a month or greater than a month.
Correct.
And so then it can choose one or the other. But what is this other piece in the middle? This one right here. Why? I guess I'm confused as to
Okay.
what its role is in the, because it seems like it's, if the data is either split to less than 1 month and greater than 1 month, then I guess I don't understand
So
what.
yeah. So let me clarify that a little bit. Let me erase this guy. So this one, let's say, for example, I'm in 2015 now. My first backup server is filled up. So anything older than 2015, um, let me anything older than 2015 will get into this machine.
Okay.
For
Here,
example,
I can help erase the old stuff if we want to erase it.
yeah, sure.
Uh,
Is there a way?
yeah,
Uh,
you just have to make the eraser a little bit bigger. It's fine. Yeah. Okay.
the eraser. It is just
So
okay.
then there's a little circle right above the
Oh,
eraser,
okay.
and you
I
can
got
choose
it.
how big the eraser is. Yeah.
I got it. Got it. Okay, let me do it. So, for example, this one.
Okay.
So, oops. Okay, I'll have to go back. Okay. So, this one contains less than 2015 data,
Mm-hmm.
and then anything. So now we learned this database is filled up, and then we are adding a new machine, and this will contain anything greater than 2015, like greater than or equal to 2016, for example.
Okay.
so so going forward from the OLTP machine, I'll just start backing up things every month to get into this database machine 2.
Okay.
That's kind of the backup service that we will write, which will run in offline mode.
Okay.
So so this load balancer decides. So this load balancer itself could understand the machine 1 and machine 2,
Mhm.
and depending upon the query, we can pass. We have to split the query depending upon, let's say, if someone asks, since it is like a pretty recent, if someone asks like 2 months of 2015 and 1 month of 2016, then definitely this load balancer really have to pass the query and send to the two machines, so
Mhm.
that we get both the rows and then join and then send it back.
Okay.
So that's kind of a load balancer's job, and it can be configurable. We can say, okay, 2015 year 2015 machine 1 and all that. Probably we can put it in some XML configuration or something,
Mhm.
where the strategy kind of easily changeable and stuff, so we can add more machines going forward. When we add machine 3, we can just say 2017 and above, So that can be configured just like that in the configuration file here. So this
Okay.
will be read by load balancer, something like that.
Okay. Now that makes sense. Okay, so it seems like so we started off with the idea of it being geographically partitioned, and that's good.
Correct.
That will work with some things. And this is partitioned by time. And
Right.
so in what type of scenario is this going to be ideal? Like what kind of query patterns of people querying the database are you going to see that this is optimal for?
So this is completely for like a transactional database where, like, let's say Amazon order service where you get plenty of orders every minute and every day. So probably that's kind of amount of data where you get it from same country and you would get a lot of orders. That's probably one scenario where you get like tons of records every day.
Well, let me put it this way. So, for example, let's say we're talking about a Amazon-like database, and
Okay.
the things you're storing are things like orders, like who ordered what, right?
Right, right.
And I could imagine that in this type of situation, people are looking up recent orders more
Mm-hmm.
often than they're looking up past orders, right? So
Correct.
they're probably looking up something that they just ordered this past week
Yeah.
to see its status, but they're probably not looking up very often their old orders.
Well,
So it
correct.
kind of feels like you're going to get a lot of traffic going to this one machine,
One machine.
and
Mm-hmm.
then all of the backup machines are going to be less
Sitting idle.
utilized.
Uh-huh.
So can you think of a way? So let's even just keep going with the this sort of Amazon style database, and let's just say that after putting this into place, you notice that this one machine here gets kind of most of the action and becomes the bottleneck, and these older ones, people aren't really querying for it that often, and so they're less utilized. Can you think of some way that will sort of better distribute the workload between all of these different machines so that you don't have this one as the bottleneck?
Yeah, sure, definitely. So I think so the other way to distribute would be probably like going by since country wasn't a thing because every order is coming from same country. Let's say, for example, everything from North America. In that case, I would say just go with a last name. Usually, like if we go by last name, people query by so the user identification, user ID, of course, is not the thing we can do. Probably I would go with last name starting from A to let's say P to machine 1, from Q to Z to machine 2, and depending upon number of machines I have, I can split evenly to all the machines. So but this scenario I'm thinking about is just the orders. Like it can vary the condition that we are trying to the approach we are trying to split the data between the machines depending upon the data we are getting. For example, right now we are thinking everything is orders, everything is placed by some first name A and last name B. In that's the scenario I'm completely talking about. So in that way, any user come to query something, they go to just one machine. They will never get into multiple machines, and there is no question of joining queries and merging the data from two different machines and then serving the users. So that's probably one approach I would go with. Go by
Okay.
last name.
Okay. No, that sounds excellent because that's definitely going to spread it out so that all of the machines are getting, the current orders and the past orders. So all the
Correct.
machines are kind of spraying them out. So that's great.
Correct.
So
But
now I'm going to put in another challenge for you here. So if you split it up by letter, some letters are going to be more popular than others. So there's many more last names that start with the letter T than start with the letter W.
Exactly. So I was actually coming to it.
Okay, great.
Uh, yeah. So I was thinking of see the pattern of orders coming from. We really have to study the pattern last like a few months and see where the number of orders really coming, and that's how we have to decide the number of letters to go into some machine X and machine Y. um, there is no way we can really distribute just 12 letters to, sorry, like 13 letters to one machine and remaining 13 letters to the other machine. Definitely we have to see the pattern, how the last couple of months went through, and depending upon that we'll have to decide, okay, probably like 5 letters, first 5 letters to machine 1, remaining 21 letters to machine 2, probably something like that. And one more problem with this again, for example, if you, since you are storing order and everything here, split it into multiple machines, um, in a case of like where the same order database will be accessed by some people like who's fulfilling the orders, in that case we have to really query. We cannot really query by name or anything. They have to see just what all orders today, and definitely we run into issues of pulling the data from two different machines and then merging and then joining everything and then returning all the data. So there is no way we can get around like you're always hitting one machine. That's not high likely. Like it is just one side we are solving the problem, but the other side we still have the problem of solving querying from multiple machines and then joining. So yeah.
Okay, that's a very good point. It's a very good point. So just going back to that last issue, like if you said that you wanted to find all the orders, so let's say we're going into the way you said before with all the last names, and so that's now distributing the data a little bit better, but now the dates are not distributed very centrally. So now you want to issue a query that says, show me all of the orders today.
Right.
So where is the bottleneck going to be in that case?
It's all going to be the load balancer, where so the load balancer is the one will get all the requests. Now it has to decide where to go pick the data. Now machine 1, machine 2, machine 3, for example, if you want everything from today, it has to go to all the machines, and you got all the data from all the machines. You have the job of joining everything and then like union all the results and then returning to the client. So the load balancer kind of becoming a bottleneck here.
So that's certainly true if you're doing some aggregation of all the data. So let's say that you wanted to sort all of the today's orders, then certainly you're right that the load balancer would become the bottleneck because it would have to aggregate all of them and then sort of sort them. But what happens if they just ask, give me all of today's orders in any today's purchases in any order? I'm not concerned about the order.
Okay. So so in that case, so there could be one more possibility where you get the client request, and I know the load balancer knows where all the data is, and we could potentially return the results directly from machine 1, machine 2, machine 3 to the client. Possibly. The way is, you from the load balancer you will get only, it's the load balancer is probably act like a velocity server where the client will get the data, the information, where to go pick actual data. So I will return back machine 1, machine 2, machine 3 to the client, and then client will query one more like a 3 parallel queries or whatever kind of the way, it can just go query directly from those machines. So the load completely is split between all the machines.
No, that's an excellent idea. I like that. I like that. Okay, so last one. So we're these are all excellent ideas. So let's just dig a little bit deeper into the last name issue. So you're right. I really like that idea of looking over some past data, like usage patterns, to sort of see
Mm-hmm.
who are the types of users that use it more often and that kind of thing. And that's certainly something you can do dynamically.
Right.
But let's try to think of something that you can do more statically without looking at the usage patterns to try to
Okay.
clear up this issue of more people have last names with the letter T than have the last names with the letter W. So is there some way that you can distribute the records so
Mm-hmm.
that so that even if so let's just say, for example, that you have 100 machines, and
Okay.
hypothetically this would mean you would put 4 letters on each machine because there's basically 25 letters in the alphabet. But as it turns out,
You mean each letter in 4 different machines?
yeah, so you would put
Okay.
like the first quarter of the letter A would go in one machine, and the
Correct.
second
Correct.
quarter of A gets in the second machine, etc.
Yeah. Yeah.
But so that's the sort of one way to do it.
Mm-hmm.
But it turns out that if you put like you could fit all of the complete letter Z in one
Mm-hmm.
machine, and
Mm-hmm.
actually all of letter Y too, because there's not very many people with last letters Y. So
Correct.
so two
Correct.
people can actually fit in Y,
Mm-hmm.
but the letter T needs 10 machines.
Correct. Okay.
So, I mean, one way you could do it is you could just sort of keep a table of each individual row with, well,
Oh, yep.
oh yeah, back. So, I mean, one sort of simple way of doing it would be to create a table with each individual row and which machine it's
Mm-hmm.
going on, or you could create like a range. You could say, well, this person to that person
Mm-hmm.
is on this one machine, but there's kind of a lot of bookkeeping to do there. Can you
Mm-hmm. Mm-hmm.
think of sort of a simpler way so that when a query comes into this load balancer,
Okay.
it knows exactly where to go very quickly and easily
Okay.
for which machine is holding that person's data, and uh, and you don't need to keep any type of like bookkeeping around that. I mean,
Oh,
so the
okay.
bookkeeping is fine, except that let's say you wanted to add someone to the database,
Mm-hmm.
then or you want to add an order, well, you would kind of be constantly shifting around how they're all migrated if you wanted to
Yeah.
optimize it. So
Mm-hmm. Mm-hmm.
so can you think of a way that is going to distribute all of these people
Mm-hmm.
in in a way that each machine is not overloaded, that all of the machines have this roughly the same number of records,
Mm-hmm.
and that you don't need to do any type of like heavy duty bookkeeping or shifting around of data as say more people come online or more
Okay.
orders are made.
Okay. So I was just quickly thinking of just putting the machine in, mapping the machine with the user table where each record will say, okay, this user always goes to this machine, blah.
Mm-hmm.
But that's easy in a way to just to return the machine or whatever the detail we want to store the data for the user thing. But in a way, it becomes complicated. Let's say what happens if I have to bring one machine down. I'll have to really go back, find all the users assigned to that machine, and then update with some new machine. um, those are the things we have to really think about. But let me think about little more. So what I was thinking was giving some weightage, but that's again that sounded like a heavy duty. bookkeeping kind, where I say starting letter A gives some weightage 1, so and T with a lot of orders probably weightage 10, something like that. So giving weightage for the letter again, I think kind of a high bookkeeping. I wouldn't suggest.
Yeah, how would
You think of it.
you pick the weight? So the idea that the weight is the number of users with that letter. So like the weight for the letter P is how many users' last names start with the letter P, that kind of thing.
Yeah,
Okay.
yeah. So that's probably the dynamic. So when
That's there's something to that. That's an interesting one. I hadn't thought of that one before, but that makes some sense. So so then what would you do with that weight?
yeah, so the weight tells you, let's say you have 100 machines, it will just split up with that weight will tell you how many machines, what is the percentage of machines that you need for that each letter. So you just sum up and then then find the weightage percentage for each letter, and then depending upon number of machines, you can just have those many machines for that specific letter. But that's again another bookkeeping. The other approach I was thinking was, since we evenly need to distribute every order comes in. So let's say we want to like a very very highly distributable model, where you get order 1, go machine 1, order 2, machine 2, order 3, machine 3, and order n go to machine n, and order n plus 1 goes to machine 1 again. That
I like that idea. I like that idea very much.
Yeah, but how we really achieve that is what really becomes more of questionable. Where, let's say if I have order 1, order 2, order 3, I get from one user. Let's say if I go to machine 1 and I say, okay, machine 1, order 1 from user 1 is always machine 1. I could assign the user 1 from then on, go to always machine 1. And the next order goes from user 2 goes to machine 2. I will assign that user for the machine 2.
I see.
But again, that becomes static afterwards. That's not more of dynamic anymore. So there should be a better way of distributing always all the machines used like equally. That's what I'm
But
hoping to come
actually,
up with.
let's explore this latest idea that you had, which I actually think is quite elegant because of its simplicity. That you'll have the load balancer as you're writing new things.
Right.
Will just have a counter that will roll over. Super simple to figure out where it's going to go. And so then the only question is,
How to get it.
how do you retrieve it?
Yeah. So so the reporting again becomes complicated there.
Well,
So
maybe not.
maybe not.
I mean,
Yeah.
so if you think about it, so let's say that you have you say, well, give me all the orders from today for some certain user. That's what that's what you want to query. So
Right.
what can the load balancer do to find that information, given that it is totally forgotten where it's put that person, because maybe it saw that person a million transactions ago and it didn't keep track of where it put that person.
Right.
So how can you get at the, how do you get at the answer to that query of, how many purchases did that person make today?
Right. So one since these are all reporting afterwards, we could potentially. I'm just thinking of so there are two things, right? One is OLTP and the other one is OLAP, where the analysis server, which is just for used for reporting server. Quite possibly that we can have all these machines data and the transaction data gets duplicated or pushed to some reporting servers where this load balancer always can go query the data from. So that's um let me think. So let's say we have 100 machines here. The main reason we are distributing is because users are being online and we need to serve them quicker and faster. That's the main reason that we are distributing all these transactions during the insertion. But the reporting usually can, like, a couple of seconds can take a couple of seconds more. We could potentially have the reporting servers separate, where all the data gets synced to the reporting servers. Always the load balancer knows if any query for just querying the data, always pointing to the reporting servers. Um, that is one possibility. But let's think of if there is any other way that we can always pull this data from the same machines where we inserted. I I don't see, because we lost the pattern. As you said, the load balancer forgot where the data went. There is no way the load balancer is keeping this mapping between the machines and the pattern of queries. Um, Let me think a little bit more. Hmm.
So
That's
one
really
thing
interesting.
that you're optimizing for, which is generally a good thing, is that you're trying not to ask more machines than necessary. So,
Mm-hmm.
for example, with this first description that you have here, with the where it's sharded by time, you have the less than 1 month, and then 2016, 2015. You have
Mm-hmm.
the load balancers up at the front that decides I'm going to ask only one of these machines,
Right.
and that saves CPU cycles, obviously,
Yeah.
because you're only asking the one proper machine where it is. But
Right.
that's not necessarily a restriction. You could ask more than one machine.
Mm-hmm. Mm-hmm. Yeah, definitely. So in case of, let's say we have 100 machines, we store the data like evenly from the load balancer. Now the query is to select something. I could go ask more machines, but 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 my worry is that would slow down things when someone wants the report of, like, today's orders or last 1 week's orders or whatever. Querying more machines will slow down things if it is just from the load balancer.
Well,
So there
actually, if
could
you
be
think
an.
about it, so if you're the reporting server and you're trying to get all the days orders,
Mhm.
you still have to ask every single machine, because somebody with the last name with the letter P is going to have an order, and someone with the last name of the letter
Right.
Q is going to have an order. So you have to still ask all the machines when you're
Mhm.
reporting. So I
Yeah.
think
Yeah.
that's actually not a big problem. I don't think it slows down the reporting aspect of it.
Okay. Um. Yeah. Yeah. So could be, that's again the load balancer. Probably, let's say if it is just a select query, then we could have an so the probably we need to distribute the load balancer now. The problem is all the insertion going through the load balancer, one single server balancing everything. And if it finds something, select query or the reporting query, it should just give it back to the client, go ping the other load balancer or something. On that machine, the other load balancer just mainly for the reporting load balancer, and this is probably the just the transaction load balancer. So the second load balancer where the all the reporting queries go in, and that would probably easily to query from all machines and then respond, serve the user. So that way we could just split the load between the load balancers potentially. um, but I would not really suggest just this machine querying all the machines for the reporting purpose, and as well as the same load balancer doing all the insertion to all different machines. That will really become a bottleneck, I think.
So I have a
Just
question. So in this, if I'm understanding this iteration, there's going to be multiple load balancers, and each one of them is going to query all of the machines, or is going to query some subset of the machines. I guess I don't
yeah.
understand the
So
multiple levels of
load balancer,
load balancing. And I guess
right?
the other question is,
Mhm.
why can't the original load balancer just ask all of the machines in parallel what all the
Uh-huh.
results are?
It can. It can. I'm just worried whether it will soon become a bottleneck for responding the request, because it's doing all the insertion, as we are talking about the data like Amazon size, like
Mhm.
all the orders coming through this load balancer, and as well as you are doing the reporting through the same load balancer, which is scoring all different machines.
Mhm.
um, I'm really worried that will become really a bottleneck and slow down things. So what I was proposing was, if whenever this load balancer gets a reporting query, I know, okay, this is just a report. Go back to the client saying, okay, this is just a reporting. Go to the other load balancer. So now the client hits this load balancer too. This knows, okay, I deal with just the reporting part of it. That will still query all the machines, but not the same load balancer. So this load balancer one will just do the insertions and stuff like that. All reporting will go through the load balancer two, which will parallelly query from all the machines and then serve the user. Does it make sense?
Okay, yeah. So
Hmm.
if I'm understanding that, uh, it would sort of be introducing like a priority or a tier
Correct.
for the different load balancers, and depending on what they were doing, they would sort
Hmm.
of have a higher or lower priority to
Correct.
use up the resources. That's very smart, yeah, because you're right that the usage of the database is not going to be the same. So
Correct.
a user who's just logging into the site is going to want to see a small number of records very quickly,
Hmm.
whereas
Yeah,
the reporting server is looking at a very large number of records but can see them more slowly. So
that's correct.
that's great. That makes sense. Yeah, that's all I had. I know it's a very open-ended question, but was just curious. Wanted to just talk with you about that. It sounds like I don't know if you've ever done any thinking about this. It seems like you must have thought about this some because yeah, you have all this ideas about load balancing and OLTPs and usages and sharding. It sounds like you know all of the concepts very very well. So
Thank
do you
you.
do this in your in your work already? I know I don't
Yeah.
normally see people that have this much background in all the various contexts.
Sure, I did some amount of this work in the past. So I was working really the same kind of ordering platform, one of the highly available, like a million users kind of database I was dealing with. So we ran into the same similar kind of issues, and we were trying to do like a multiple few things like this, and exploring. It was all again learning and settling down things. There is no just one best solution for everything.
Hmm.
It is
Yeah,
just
that's definitely true.
yeah, yeah. So that's why, like, trying to understand the patterns a little bit, and then making sure we balance things like evenly is really important. But did you have any other better ideas, just in case? Just
Oh, so
making sure.
so I do like the one idea of the just having a round robin where you'd put each um, um,
Recurrent
user
to.
record over that kind of thing. The other way to do it, by the way, is with respect to the names.
Okay.
Um, if you wanted to do it based on names, what you could do is instead of it being based on the first letter, you could just take a hash of the entire name or the entire
Okay.
user ID or something like that. So
Mhm.
then what that hash will do is say, take some space of, 100,000, a million, 2 million users
Mhm.
and break it down into a number between, one and however many machines you have. So just design your hash function so
Mhm.
that it takes whatever your identifier is, be it their name or their ID or something like that,
Okay.
and remap it into a space that is exactly how many machines you have. So that way you can avoid the problem of querying too many machines, and
Mhm.
and there's sort of a lot of network traffic
That.
that's excessive. But what you could do is you could you just hash the person's identifier, and then you know that that
Mhm.
identifier will go exactly to that one machine, and that
Mhm.
way, as you add more and more users, they just get randomly assigned according to that hash function.
Mhm.
So
Mhm. Yeah,
it's
that's a
another way,
great
but
idea.
yeah, but as you said, there's no one right answer. You know, the
Yeah. Yeah.
practical nature of your data will pick whatever the right one is. And I thought you had a lot of really good ideas, so that's great.
Mhm. Mhm. All right. Yeah. Yeah. That's a good thinking of doing the hash function. Yeah. Yeah. That's something new I learned today. Good.
Great. All right. So you have a good day.
Thank you so much. You too.
All right.
Bye bye.
Take care. Bye.